Hello everyone, my name is Anuputra. So today I am going to discuss about unit number 4, input output organization, lecture number 25. So the contents that we are going to discuss in this video is bus arbitration, buses, synchronous bus and asynchronous bus. Bus arbitration. Now the device that is allowed to initiate data transfer on the bus at any given time is called as a bus master. So there is a device that allows data transfer on the bus. So that device we call it as a bus master. So bus, as you know, it used to allow data to pass from one component to another. So when the current master relinquishes control of the bus, another device can acquire this status. Now bus arbitration is the process by which the next device to become the bus master is selected and the bus mastership is transferred to it. So two or more devices always try to get the control over the bus. So when the next device becomes is ready to become the bus master and it's selected and bus mastership is transferred to it, that is called as bus arbitration. So the selection of the bus master is done by establishing a priority system for gaining access to the bus. Now there are two approaches to bus arbitration, okay, centralized and distributed. So in centralized arbitration, what happens? A single bus arbiter performs the required arbitration, okay? Whereas in distributed, all devices will participate in the selection of next bus master. So there may be a printer, keyboard, so all the devices will participate in the selection of next bus master, whereas in centralized, only a single arbiter performs the required arbitration. Let us see what is centralized arbitration. So as you can see here, the diagram showing centralized arbitration. So the bus arbiter may be a processor or a separate unit connected to a bus. So it shows the arrangement in which processor contains the bus arbitration circuit. Now the processor is normally a bus master always. So it is a bus master till it grants bus mastership to one of the DMA controller. So now currently the processor has control over the bus transfer the data. So it can grant the again membership to DMA controllers. So DMA controller indicates that it needs to become the bus master by activating the bus request line. So by activating the bus request line, it can become a bus master. The signal on the bus request line is the logical out of the bus request from all the devices connected to it. Now, when bus request is activated, the processor will activate a bus grant signal, that is BG1, which indicates to DMA controller that they may use the bus when it becomes free. Now, this signal is connected to all DMA controller using a daisy chain arrangement. Now, so if DMA controller is requesting a bus, so it blocks the propagation of grant signal to other devices, so that other devices should not grant access to this bus. So it is called as a centralization, that is only one devices can act as a bus master. So DMA controller 1 currently has control over the bus master because DMA controller is set to 1. Otherwise it passes the grant signal using BG2. Okay, so if it does not want, it can pass the grant signal to BG2. So DMA control if it gets the bus master, so it will block the propagation of grant signal to other devices. Now the current bus master indicates to all devices that it is using the bus by activating open collector line called as bus busy. Now you can see here bus busy. So why it will activate is by telling to the other devices that I am using the bus arbitrate, that is the bus line has been used by it, so it is using the line, so the other bus master should not use it. As you can see here, the bus base signal, the current bus master, suppose DMA controller is using the current bus master, so it sends a bus base signals to all the devices saying that it is using the bus, so that other devices should not request for a bus signal. After receiving the bus grant signal, a DMA controller will wait for bus busy to become inactive. Okay. Now suppose processor has control over the bus. Now once a DMA control waits for bus busy to become inactive, the bus is becoming busy with the processor. So when it's become activative, then it assumes mastership of the bus. At this time, it activates bus busy to prevent other devices from using the bus at the same time. So as I told, when processor is using the bus, it will activate the bus base signal. So when it gets inactivated, so DMA control activates the bus base signal, saying that so that it can prevent the other devices from using that bus at the same time. So it shows the timing diagram, so the sequence of events in which DMA controller 2 requests and acquires bus mastership and later release the bus. So there's a bus master now. The first processor is a bus master. Okay, so it will send the bus request signal. Okay, so after sending the bus request signal, and then we have a so the processor, after getting a bus request, it will send a BG1 signal. Okay, saying that the bus master is ready to forward the signal, as we have BG2 and BBSY. So there are three bus masters here: processor, DMA controller 2, and the processor. So this is how the timing diagram shows. So when DMA controller 2, as you can see here, DMA controller 2 acts as the bus master. It may perform one or more data transfer operation depending on whether it is operating in a cycle, stealing, or block mode. So after it releases, it is then passed on to the processor. So here we have discussed about centralized arbitration. Now we discuss about distributed arbitration. So here you can see the diagram of distributed arbitration. So as I told, multiple devices can use the buses at the same time. Now it means all the devices waiting to use the buses have equal responsibility in carrying out the arbitration process, that is without using a central arbiter. Now figure shows a simple method for distributed arbitration. So each device on the bus is assigned a 4-bit identification number. So as you can see here, each devices will be assigned a 4-bit identification number. So when one or more devices request the bus, they assert the signal and place their 4-bit ID numbers on phone open collector lines. So on 4 open collector lines, they will open the 4-bit ID. Now winner is selected as a result of interaction among the signals over the lines by all conductors. So the net outcome is that the code on the 4 lines will represent the request that has highest ID number. So the number code which has the highest number will win the and acts as a bus master. So the bus includes the lines needed to support interrupts and arbitration. So bus protocol is a set of rules that go on the behavior of various devices connected to the bus. Now bus lines are always used for transferring data of three types, that is data, address, and control lines. So the control signal will specify whether a read or write operation is to be performed. So it may also carry timing information, also specify the time at which processor and input output device may place data on the bus or receive the data on the bus. Now the device may be addressed by the master is referred to as slave or target. Now we see various different types of buses. What is asynchronous bus? Now in asynchronous bus, all the devices derive timing information from a clock line. Equally spaced pulse on this line will define equal time intervals. So as you can see here, now each of these interval constitutes a bus cycle during which one data transfer can take place. Such a scheme is as shown in the figure. So as you can see here, it is taking place asynchronously. Now the address and data lines are shown as high and low at the same time. Okay, as you can see here, address and data line, they are at the same level. The crossing points indicate the times at which these patterns will change. Okay. Now a signal line is an intermediate or high dependence state and is represented by an intermediate level halfway between low and high signal. Now let us see about how the read operation takes place. Now let us consider the sequence of events during an read operation. Okay. Now at the time t0, the master places the device address on the address lines. okay, and sends an appropriate command on the control line. Now, information travels over the bus at a speed determined by its physical and electrical characteristics. Now, slave takes no action or places any data on the bus before T1. Now, information bus on bus is enabled during the period T0 to T1 because signals are changing state. Now, the address slave places the required input data on the data lines at time T1. So, at time T1, input data line will be activated. Now, end of the clock cycle at time T2, the master strobes the data on the data lines into its input buffer. So, strobe means to capture the values of data at the given time. Now, the period T2 minus T1, as you can see here, is greater than the maximum proportion time on the bus. Now, how the write operation is done? Here you can see here a similar procedure is followed to an output operation. The master places first the output data on the data lines. Okay, so when it transmits the address and command information. Now at time T2, the address device strobes the data line and loads the data into its data buffer. So the timing graph as shown in below. So it has one will show the signal as seen by the master and another will be seen by the slave. Okay. Now the master sends the address and command lines on the rising edge of the beginning clock period T0. So at T0 at the beginning rise it will send the data. Okay. Now at the same time, after some time, the TS the signals will reach the slave. So at the same time it will reach the slave. The slave decodes the address and at T1 sends the requested data. So at T1 the requested data will be sent. Again the data signals do not appear on the bus until TDS. So until TDS the data signals do not appear. Multiple cycle transfers. So a high frequency clock signal will be used such that a complete data transfer cycle would span several clock cycles. That is, the number of clock cycles involved can vary from one device to another. Now during clock cycle 1, the master sends the address and command information on the bus requesting a read operation. The slave receives this information and decodes it. On the following active edge of the clock, that is beginning of clock cycle 2. So at the beginning of clock cycle 2, it makes a decision to respond and begins to access the requested data. Okay. Now data becomes ready and placed on the bus in clock cycle 3. So in clock cycle 3, the data will be placed. At the same time, slave assets the control signals called slave ready. Now you can see here the master, which has been waiting for the signal, strobes the data into its input buffer at the clock cycle 3. So at the input clock cycle, you can see there is a change and it strobes the data into the input buffer. Now bus transfer operation is now complete and the master may send a new address to start a new transfer in clock cycle 4. Now we see what is a synchronous bus. Now for controlling data transfer on the bus, handshake between the master and slave will be used in a synchronous bus. Now a common clock is replaced by two timing control lines. So it's called as master ready and slave ready. So the first one will be set by the master to indicate that it is ready for transaction, and the second one is a response from the slave. Now the data transfer controlled by a handshake protocol is as follows. So what we do is the master will place the address and communication information on the bus. Then it indicates to all devices that it has done so by activating the master ready line. Now this will cause all the devices on the bus to decode that address. Now the selected slave, whichever devices or selected slave, will perform the required operation and inform the processor that it has done so by activating the slave ready signal. So once it activates the slave ready signal, means it has received this information. Now the master waits for slave ready signal to become asserted before it removes the signal from the bus. Now in data operation, it also stores the data into its input buffer. The sequence of events are as follows. Now the T0, you can see here, the master places the address and command information on the bus, and all the devices on the bus will begin to decode this information. Now at the time t1, you can see the master sets the master edit to 1, means the master has placed the address and command information on the bus to so it will inform the important device that it is address and command information is ready. Now when the address and information arrived at any device, it is decoded by interface circuitry. Now at time t2, the selected slave among the devices, so what it will do is and command performs the required input operation by placing the data from the data register on the data lines. Okay. At the same time, it sets the slave ready signal to 1. So if it sets slave ready signal to 1, it means that it has performed the required operation. Here bus gives its asynchronous nature. Now slave ready signal arrives at the master, indicating that the input data is available on the bus. Okay, at the time t3, at the same time it drops the master ready signal. Okay, so as you can see here, the master ready signal has been dropped, indicating that it has received the data. At the time t4, the master will remove the address and control lines, okay, from the bus. Now the delay between t3 and t4 is again intended to allow the bus queue. Now at the time t5, the device interface receives the 1 to 0 transition of the master ready signal. Now it removes the data and the slave ready signal from the bus. So this will complete the input transfer. Now we see what is the output operation. Now in this case, when master will place the output data on the output data lines, and at the same time it transmits the address and command information. Now again the same procedure, the selected cell will store the data into its output buffer when it receives the master ready signal and indicates that it has done so by setting slave ready signal to 1. Now the handshake signals in both the figures are fully interlocked. A change of state in one signal is followed by a change in another. So this scene is known as full handshake. So in this video we have discussed about bus organization, centralized and distributed arbitration, working of synchronous and asynchronous bus. Thank you.